Evaluation of mutually exclusive alternatives. Most engineering projects can be accomplished by more than one feasible design alternative. When the selection of one of these alternatives excludes the choice of any of the others, the alternatives are called mutually exclusive. Typically, the alternatives being considered require the investment of different amounts of capital, and their annual revenues and costs may vary. Sometimes the alternatives may have different useful lives. The fundamental question is, do the added benefits from a more expensive alternative bring a positive return relative to the added costs? If the extra benefits obtained by investing additional capital are better than those that could be obtained from investment of the same capital elsewhere in the company at the MARR, the investment should be made. Rule number 1. When revenues and other economic benefits are present and vary among the alternatives, choose the alternative that maximizes overall profitability. That is, select the alternative that has the greatest positive equivalent worth at I equals MARR and satisfies all project requirements. Rule number 2. When revenues and other economic benefits are not present or are constant among the alternatives, consider only the costs alternative that minimizes total cost. That is, select the alternative that has the least negative equivalent worth at I equals MARR and satisfies all project requirements. Study period or analysis period. The study or analysis period, sometimes called the planning horizon, is the selected time period over which mutually exclusive alternatives are compared. The useful lives of alternatives being compared relative to the selected study period can involve two situations. First is, useful lives are the same for all alternatives and equal to the study period. Second, useful lives are unequal among the alternatives, and at least one does not match the study period. Unequal lives among alternatives somewhat complicate their analysis and comparison. To conduct engineering economy analysis, in such cases, we adopt the rule of comparing mutually exclusive alternatives over the same period of time. The repeatability assumption and the coterminated assumption are the two types of assumptions used for these comparisons. First one is coterminated assumption. Useful lives are equal to the study period. The coterminated assumption uses a finite and identical study period for all alternatives. This planning horizon, combined with appropriate adjustments to the estimated cash flow, puts the alternatives on a common and comparable basis. When the useful life of an alternative is equal to the selected study period, adjustments to the cash flows are not required. The most straightforward technique for comparing mutually exclusive alternatives when all useful lives are equal to the study period is to determine the equivalent worth of each alternative based on total investment at I equals MARR. Then, for investment alternatives, the one with the greatest positive equivalent worth is selected. And in the case of cost alternatives, the one with the least negative equivalent worth is selected. Second is repeatability assumption. Useful lives are unequal among alternatives. When the useful lives of mutually exclusive alternatives are unequal, the repeatability assumption may be used in their comparison if the study period can be infinite in length or a common multiple of the useful lives. This assumes that the economic estimates for an alternative's initial useful life cycle will be repeated in all subsequent replacement cycles. Another viewpoint is to consider the repeatability assumption as a modeling convenience for the purpose of making a current decision. When this assumption is applicable to a decision situation, It simplifies comparison of the mutually exclusive alternatives. With repeatability, we will simply compute the AW of each alternative over its own useful life and recommend the one having the most economical value. Example is the alternative with the highest positive AW for investment alternatives and the alternative with the least negative AW for the cost alternatives. The repeatability assumption involves two main conditions. First is the study period over which the alternatives are being compared is either indefinitely long or equal to a common multiple of the lives of the alternatives. Next is the economic consequences that are estimated to happen in an alternative's initial useful lifespan will also happen in all succeeding lifespans or replacements. There are two cases. First one is useful life is less than study period. Cost alternatives. Because each cost alternative has to provide the same level of service over the study period, contracting for the service or leasing the needed equipment for the remaining years may be appropriate. Another potential course of action is to repeat part of the useful life of the original alternative and then use an estimated market value to truncate it at the end of the study period. Investment alternatives. The first assumption is that all cash flows will be reinvested in other opportunities available to the firm at the MARR to the end of the study period. A second assumption involves replacing the initial investment with another asset having possibly different cash flows over the remaining life. A convenient solution method is to calculate the FW of each mutually exclusive alternative at the end of the study period. The PW can also be used for investment alternatives since the FW at the end of the study period, say N of each alternative, it's PW times a common constant where I percentage equals MARR. Next case is useful life is greater than study period. The most common technique is to truncate the alternative at the end of the study period using an estimated market value. This assumes that the disposable assets will be sold at the end of the study period at that value. The underlying principle is to compare the mutually exclusive alternatives being considered in a decision situation over the same study or analysis period. When repeatability assumption is applied, simply compare the AW amounts.